All right, now we're going to get into conditional probability. Oh, it was my baby boy's birthday on January 8th, and he is 2 years old, and he is just the cutest in the whole world. I just needed to share with you guys because hopefully you love my dog too. All right, independent events means that each event is not affected by other events, and we kind of talked about this in that packet you guys were supposed to go through. And then dependent events means that they are affected by the previous event. So like one example of that would be pulling marbles out of a bag. So like you could pull the marble out the first time, and then the probability of you like pulling 2 blue marbles depends on what you pull out the first time, right? And then there's with replacement. When you replace it, that means it's independent. Without replacement means they're dependent, okay? So some just notation here. P of A means probability of an event happening. Conditional probability would be P and then B/A. And that means the probability of event B happening given event A already happened. Okay, so that is conditional probability right there. In other words, event A has already happened. Now, what is the chance of event B happening? We got this. Okay, so let's look at this first example. So a student compiled the following contingency table comparing the amounts of land area and water in square miles in various U.S. states. We want to know the probability that a point chosen at random on a map is water given that the map is Florida. So we are given a map of Florida. Okay, and we want to know if I just was to close my eyes and put a pin down, what is the probability that I will land on water? Okay, so we need to look at Florida here. Well, this right here is the land mass. So this is the total land mass, and this is the total water. Well, together, we just have to add those together to get the total square miles of Florida. So if we add those together, but then we want to only know the water, so I'm going to divide the 1177 on top. 11,777,000. Okay? So in Florida, there's 54,018 square miles of land and 11,777 square miles of water. So the probability of picking water, given that it's Florida, would be 11,777,000 divided by that added together. So you get that fraction, which is about 0.179. So that would be 17.9%. Cool? Let's do another one. So this one, researchers asked shampoo users whether they apply shampoo directly to their head or indirectly using their hand. Who does that? I'm so confused. But do any of you like just squirt shampoo right on your head? Like maybe I should start doing that. Maybe it's easier. I don't know. Anyways, what is the probability that a respondent applies shampoo directly to their head given that the respondent is female? So given that they're female, what's the probability that they just like squirt shampoo right on their head? Well, there's 6 of them, 6 out of the 30 that squirt shampoo right on their head. So that's going to be 6 out of 30, which is 1/5, which is 0.2. So 20%. There's a 20% chance that I pick a random female and that female squirts shampoo on their head. That's weird to me, but whatever. Okay, cool. Now tree diagrams. So these help us when determining probability. So let's look at this. We have the chance of rain for the next evening is 60%. If it rains, the chance of lightning is 80%. And if it does not rain, the chance of lightning is only 5%. And we want to know the probability that it will not rain and there will be no lightning. So first, let's start with like our tree here. So there's a 60% chance it rains, which means that there's a 40% chance it doesn't rain. Okay, and if it rains, there's an 80% chance there'll be lightning, and there's a 20% chance there'll be no lightning. But if it does not rain, there's still a 5% chance that there will be lightning, which means there's a 95% chance there will be no lightning. Okay, so using this, we can figure out the probability that it will not rain and there will be no lightning. So the probability that it will not rain is 40%. And the probability that there will be no lightning is 95%. So the probability of no lightning given no rain is 95%. So we just need to multiply those two together. So we're going to have 0.4 times 0.95, which equals 0.38. So that's 38%. There's a 38% chance that there will be no rain and no lightning. Okay? I don't know. Okay, this one. So a school system compiled the following information from a survey it sent to people who were juniors 10 years earlier. So 85% of the students graduated from high school. Of the students who graduated, 90% are happy with their present jobs. And of the students who did not graduate, 60% are happy with their present jobs. And we want to know the probability that a student from the junior class 10 years ago did not graduate and is happy with his or her present job. So we need to do the tree thing. So there is an 85% chance that they graduated, and there's a 15% chance that they didn't graduate. Of the ones who graduated, there's a 90% chance they're happy, and there's a 10% chance they're not happy. Of the ones who didn't graduate, there's a 60% chance they're happy with their job, and there's a 40% chance they are not happy with their job. So then if we need to figure out the probability that they didn't graduate and they're happy with their job, well, the probability they didn't graduate is 0.15. The probability they're happy, given that they didn't graduate, is 60 or 0.6. So then that's going to be 0.15 times 0.6, which is 0.09. So that's 9%. Cool? All right, let's do this one. So a can holds 20 red balls with blue dots and 15 red balls without dots, 30 white balls with blue dots, and 25 white balls with dots. And we want to find some probabilities. So what's the probability that it's red? Well, so we have 20 red balls with blue dots and 15 red balls with dots. Okay, so that means that we have 35 total red balls, but then the total that we have here is 20 plus 15 plus 30 plus 25. So that's going to be 35 out of 90, which is 0.389, so that's 38.9%. Probability it has dots and it's red. So this is the probability given. What's the probability that it's red given it already has dots? Okay, so the ones with dots would be the red balls with blue dots and the white balls with blue dots. So to figure out if it's red with dots, well, that's going to be 20 out of the 20 plus 30. So that's going to be 20 out of 50, which is 0.4, so that's 40%. Okay, probability it has dots. So those ones have dots and those ones have dots, so that's going to be 20 plus 30 over the 90 balls total, so that's 50 over 90, 0.556, so 55.6% chance. All right, you will be missed. Goodbye and good luck.